Anyway, so let's start. Today, inshallah, we are going to do the last variation of kinematics, and that is constant acceleration. No, I wouldn't recommend that for us because today we're doing something that's not very easy. So it's best that you attend the class live. Okay. So far, let's look at what we have done so far. Okay. So that we get an idea of what's left and what to expect. So far, the questions that we have solved, the very first category that we covered basically involved displacement time and velocity time graphs. Okay. And in that, either acceleration was constant or there were instances when velocity was constant. And whatever we had to do, the graph was sufficient for us. We could have used the graph and figured out whatever it is that we wanted. Like, for example, if you wanted to find out acceleration, we can use the velocity time graph to find acceleration. If, let's say, we wanted to find out the distance traveled, we could have used the area under the velocity time graph to find out the distance. And if it was acceleration, we could have used gradient. If it was velocity, we could have used gradient of displacement time graph. So everything we wanted to figure out, we could have done that with the help of the graph. Okay. Then we did calculus applied to kinematics. Okay. In this, acceleration was not constant. Okay. In this, acceleration was basically in terms of t. So every value of t, for every point in time, you had a different acceleration, which is why we had an equation for acceleration. Okay. And then we did, we could integrate that to make velocity, integrate that to make displacement. Okay. Okay. Now what we're going to do is, we're going to do questions where acceleration is constant. Okay. Now, acceleration could be constant because of two reasons. One is that maybe it's a car, it's a train, it's a bike, it's a cycle, or maybe it's just a person who's running. Okay. The other could be due to gravity. Okay. So if you throw an object up in the air, or if you drop an object from a certain height, then even though that object has no engine or something to or any form of a driving force, the only driving force or the only resisting force, depending on which direction the object is moving, is due to gravity. So if, for example, you throw an object, if you throw an object in the air, okay, or if you drop an object from a certain height, it will start to accelerate. Okay. And since it will start to accelerate, what's the reason behind acceleration? What's the reason behind that acceleration? It's gravity. So that's why we call it acceleration due to gravity. And that has a fixed value. What value is that, by the way? What is the value of A or G? 9.81. But we take it as, we don't take it as 9.81. We take it as 10. I think you guys take it as 9.81 in physics, but in math, in M1, we take it as 10. Okay? So just keep that in mind. Acha, Zunesha, to answer your question, I hope I'm pronouncing your name correctly. No, I'm not taking P1 classes. We're done with the syllabus. Now we're just having tests. So, yeah. Anyway, now coming back. So we're doing kinematics, which involves constant acceleration. Constant acceleration. Okay. Now, like I said, constant acceleration could be because of two reasons. Okay, the acceleration could be constant because of two reasons. The acceleration could be constant because of two reasons. One is that because it's a car, okay, it could be because it's a car, it could be because it's a train, in which case you have like an engine, okay, or maybe you have someone who's running at a constant speed or running with constant acceleration, or let's say you have someone who's cycling. Okay, so this is when acceleration is constant. All in all these cases, the acceleration will have no involvement of gravity. Okay, so it's without gravity basically. The other form of acceleration is when they say the object is, let's say, dropped, okay, or if an object is thrown upwards, okay, dropped or thrown upwards, or is projected vertically upwards, thrown upwards, or if, let's say, the question says projected vertically upwards. In all these cases, we have constant acceleration, and that is basically due to gravity. In all these cases, we have constant acceleration, and that acceleration is due to gravity. And what is that? In that case, acceleration equals to g, which is equal to 10 meter per second square. Okay. Yes, Arij, I will obviously keep extra classes later on. Okay. All right. Now,
Sir,
yeah.
sir, but like when we say that the object is thrown upwards, so in in that case ये नहीं होगा कि like आप की जो acceleration है वो कम होएगी, like if we throw it upwards वो slowly कम होना शुरू हो जाएगी.
In
इस
that
इस केस में
case,
थोड़ी like
it's
when we throw
minus
it
10.
downward.
In that case, it's minus 10. Because if you throw an object from a certain height, okay, what happens to the speed? As it's coming down, what's happening to the speed? If I drop an object from a certain height, let's say like here, as it's coming down, what's happening to the speed? It's increasing, right? So it's stationary right now, it's increasing. But if I throw an object up in the air, then what happens? Then the speed is not increasing, the speed is decreasing. Why? Because the object is not accelerating, it's decelerating. Okay, the object is not accelerating, it's decelerating. In which case, what will be the acceleration? It will be negative. Negative 10. Okay, if it's under gravity, it's going to be negative 10. Okay, so it's positive 10 meter per second square. Achha, sometimes I might write it like this, or maybe I'll write it like this. Don't get confused. Okay, rules of indices, same thing. This is when the object is coming down. Okay, when the object is coming down and the speed is increasing, obviously that's going to happen. If you remember the skydiver example, as the skydiver is coming down, the speed is increasing. And what's the reason behind the increase in speed? It's acceleration due to gravity, which is acting on the mass of the diver, okay, or the diver's weight, something we're going to do later on. But if you throw an object up in the air, then it's going to slow down till it comes to a point where the velocity is 0. In that case, the acceleration will be minus 10 meter per second square. Okay, that is when the object is going up. Okay. Does the word drop indicate initial velocity is 0? So, yes, if the question says that an object is dropped, that means the initial velocity is 0. If it says thrown, then normally with thrown, you will look at the velocity that is given to you, or maybe that's what you'll have to figure out. Okay, so we'll learn what each term means eventually. Okay, now one thing that I want you guys to keep in mind, just like when we were doing calculus applied to kinematics, one thing that we should keep in mind is that this object is moving horizontally along the same path. Okay, this is not projectile motion. That's something that you guys do in physics, right? This is not, the object is not moving in in let's say a circular or in a curved manner. It's moving horizontally or vertically. Okay, so even if let's say you throw an object vertically, it's gonna move. Either it's gonna travel down vertically or it's gonna move up vertically, and then it's gonna come down the same path. Okay, it's not gonna it's not basically going to take a projectile motion. All right. Now,
Sir, I had a question.
yeah, go ahead.
So basically, in this particular section, you are dividing questions into like the questions will be divided into parts. One जिसके अंदर gravity होगी and
Yeah.
second जिसमें gravity नहीं होगी.
Yeah.
Right. So in cases like where we see a car or someone running or cycling, we will not take gravity into account.
Obviously, we not take gravity into account because that's not the reason why a car accelerates. Does a car accelerate because of gravity? Yes, it has some impact on it, obviously, but a car accelerates due to the force generated by its engine. Okay, but if you throw an object in the air or if you release an object from a certain height, in that case, that particular object is accelerating due to gravity. Okay,
Correct, sir.
in which case we take it either to be 10 or we take it to be minus 10. Okay, so basically questions like these are solved with the help of something called equations of motion. Okay, these are called equations of motion. Now you guys might have seen them. In fact, I'm pretty sure you've dealt with these in physics, or we like to call them the Suvat equations. Any idea why we call them the Suvat equations? Hmm? Any?
It's for displacement,
Yeah.
initial velocity, final
Exactly.
velocity, acceleration, and time.
Exactly. So S is basically for displacement, U is for initial velocity, V is for final velocity, A is for acceleration, T is for time. Okay. So one formula, the very first formula is V is equals to U plus AT. Okay. Now, just I'll just make a side note over here. So Yeah, it does sound like a Russian word. So basically, in this side note, we'll write what each letter represents. So S basically represents displacement. Okay. U represents the initial velocity. And V represents the final velocity. A represents acceleration, something you guys know already. And T represents time. Okay. So keep these things in mind. Now, V is equals to U plus AT. And here we can make A the subject and rewrite this as V minus U upon T, which is equal to A. You know, just like how, let's say, take cosine rule. In cosine rule, you can either use cosine rule to find the length, or you can make the angle the subject, which you can then use to find the angle. Okay, so depending on the situation we're in, we can either make A the subject or we can make T the subject. And yeah, you can just, you don't have to remember every single variation. You can just remember this, and then you can, if you have to find T, you can make T the subject. No, the derivation is not in M1. You don't have to worry about the derivation. In fact, I don't know if I should tell you guys this right now. You are actually given these equations. You are given these equations, so you don't have to memorize these. Okay, you know the formula sheet that we have. In that, you are given this, all these equations. Tero, let me just quickly show you guys. Okay, I don't have the syllabus with me. Actually, I do have the syllabus with me. I just don't remember the correct name of the file. But you do have a formula sheet where you have all these equations. You know, just like how you have circular measure formulas and APGP formulas, you have these equations given to you as well. Okay. Anyway, so now let's look at the other equation. The other equation is S is equals to 1 upon 2 into U plus V into T. Okay. Now, the other formula for calculating displacement is S is equals to ut plus half at square. Okay, S is equals to ut plus half at square, or depending on the situation, you can also do S is equals to vt plus half at square. Okay, where you take the final velocity and then time plus half at square, depending on the situation. Okay, and then the final formula, which is 2as equals to v square minus u square. All right. Now you're probably wondering, how will we know what formula to use? Okay, and rightly so. We decide that first we write down the data. So when we solve some questions, you'll understand how we come to the conclusion as to what formula we're going to use. Now, why have I made another column over here? We apply all these formulas when you have an object which is accelerating because of gravity, accelerating or decelerating. All we do is, the only thing we do differently is that we replace A with G. Okay, we replace A with G, so this formula becomes what? This formula becomes V is equals to U plus GT. Sorry, this is not 2, this is number 1. This formula becomes S is equals to, this formula remains the same, 1 upon 2 into U plus V times T, because this formula has no involvement of acceleration. This formula becomes S is equals to UT plus half GT square. Okay, and this formula also becomes S is equals to VT plus half GT square. Okay, and then lastly, 2as equals to v square minus u square becomes 2gs equals to v square minus u square. Okay, so won't that be v minus, okay, that is if acceleration is negative. Okay, if acceleration is negative, then obviously if you plug in minus 10 over here, ultimately it will become minus. Okay, please keep one thing in mind, that acceleration due to gravity will not always be minus 10. It depends on the direction in which the object is moving. If it's falling down, it's going to be positive 10. If it's going up, it's going to be minus 10. Okay, so we don't memorize different formulas. Okay, we don't memorize different formulas. It depends on the situation. All right.
So we use the same formulas for horizontal motion.
Yeah, we use the same formula for horizontal motion and vertical motion. Okay. All right. Now, acha, wait, Anas, I think I know what you're talking about. Sorry. You're talking about this formula. Okay. Is that correct? S equals to Vt minus half At square. Is this the formula that you're talking about?
Yeah, because I'm just confused because I remember in physics.
Yeah. This is minus. Sorry.
Yeah.
I thought basically it was talking about to take that we should take g as minus 10. Sorry, my bad. That's what I thought. But yeah, thank you for pointing that out. This formula is vt minus half gt square. Okay, thank you. All right, now moving on. First, we're going to do questions where we won't have the involvement of gravity. Okay, then we're going to do questions that involve acceleration due to gravity. All right. So let me take out, I have already taken out a few questions. Let's start with some very basic ones and then gradually we'll increase the difficulty level. Now, for those of you who have done this in physics, they'll probably find these retardedly easy, but we still have, it's best that we take it step by step rather than straight away jumping to the complex questions. So let's see what this says. It says a car accelerates from 4 meter per second to 10 meter per second in 3 seconds at constant acceleration. Okay, so whenever the question says constant acceleration or whenever acceleration is given to you, that is when we use equations of motion. Find its acceleration. So a good idea would be, I know this is a straightforward question, you guys have probably figured it out mentally, which is great, but normally it's best to start writing down the data. Okay, start writing down the data, keep the 4 equations in front of you, and then see which one you can apply. So we're given 4 meters per second to 10 meters per second. So what's the initial velocity? Initial velocity is 4 meters per second, okay, or 4 ms minus 1, doesn't matter how you write it. The final velocity is 10 meters per second, so that's 10 ms minus 1. The time that we're given is 3 seconds, okay? Now, what equation do you think I can apply over here? First, second, third, fourth, considering that we have to find the acceleration. The first one. Okay, here's what I'm going to do. Anas, once again, thank you for sharing this picture. I'll just airdrop it to myself. Yeah. And we will keep on referring to these equations. Okay, we can do that since they'll be given to us. There you go. Now, if you look at the 4 equations, you can clearly see that it's the first equation that we can apply over here. Okay? Because we have the final velocity, we have the initial velocity, we have time. All we got to do is find the acceleration. So acceleration is equals to v minus u upon t. That is, if you already have what acceleration looks like, if you make it the subject, then use this. Otherwise, just use the equation as it is and then eventually make a the subject. So a is equals to 2 meter per second square. And there you go. That's it. Job done. Now, the second question also is exactly the same, will be done exactly the same way. Now tell me, when the question says accelerates from rest, what does that mean? What does it mean when the question says accelerate from rest? What 0? Initial velocity will be 0. Okay, initial velocity will be 0. You're given the final velocity, you're given the time, you can find out the acceleration. No big deal. Now, a car accelerates from 3 meters per second at an acceleration of 6 meters per second. Find the time taken to reach 12 seconds. Quickly see if you guys can solve question number 3. I'm sure you guys can, but quickly solve it. Tell me what the answer is, so then we can move on towards some more complex questions. Okay, anyone who has the answer to number 3? Three seconds. All right, let me check. So initial velocity, we're given 3. Final velocity, let's write down the data. U is equals to 3 meters per second. Final velocity, we don't know. Acceleration, we can see is 6. And, wait, we do know what the final velocity is. We don't know what the time is. Okay, time is unknown. So A is equals to V minus U upon T. A is 6. Final velocity is 12. Initial is 3 divided by T. So T is equals to, no, it's not 3 seconds. It's 1.5 seconds. And there you go. That's your answer. Okay, any questions? If yes, feel free to ask. If not, then let's move on. Okay, now let's do another question. So this one is slightly more complicated. Let's see what it says. A driver sees a turning 100 meter ahead she lets her car slow down at constant deceleration of 0.4 meter per second and arrives at the turning 10 seconds later. Find the velocity she is traveling at when she reaches the turning. So, some questions will be very clear in the sense as to what the initial velocity is, what the final velocity is. Some question will the ones like the ones that have a word problem element in it. In that case, you will have to figure out what is it that the question is asking for. Okay, and in order to solve a question like this, where you have like a scenario, it's always best to make a rough sketch. Always, it's your safest bet, so that you get an idea of what you're dealing with. So a driver sees a turning 100 meter ahead. So that means if this is where your driver is, then the turning is 100 meters away. Okay? She lets her car slow down at a constant deceleration of 0.4 meter per second square. So by the way, what's 100? 100 is the displacement. Okay? Now, if the constant deceleration is 0.4, can I use 0.4 in any of the equations? Considering that it's deceleration? Will I be using 0.4 or will I use something else? Minus 0.4. Minus 0.4. Okay? Because in the equation, we enter acceleration, which is why if it's decelerating, we put it with the minus sign. Okay? Now, when she arrives at the turn, okay, which is 100 meters away, what happens? She arrives at the turn 10 seconds later. That means the time taken to travel from here to here, which is a distance of 100 meter, is equal to 10 seconds. Okay? Now, what do you think we're supposed to find over here? Think about it. What do you think we're supposed to find over here? It says find the velocity she is traveling at when she reaches the turning. Find the initial velocity or final velocity?
Sir, final?
Final velocity. Now, it may be that we have to first find the initial velocity in order to find the final velocity. That may be the case, but technically, the question is asking us to find the final velocity. Okay? This is what the question is asking for, and yes, we also don't know what the initial velocity is. Okay? Now, let's look at the four formulas that we have. Here they are. Okay, now, what formula do you think I can use over here? What formula do you recommend I use over here, looking at the data? The second one? Okay, if I use the second one, okay. If I use the second formula, we don't know u, we don't know v. Okay, we don't know either of the two. So I can't find two unknowns just from one equation. So we can use the third formula. Okay, now if we use the third formula, what do we end up finding out? We end up finding out the initial velocity. Okay, if I use the third formula, we end up finding out the initial velocity. So s is equals to ut plus half at square. Okay, so what's s? S is 100. Ut, what does that mean? That means 10 u, because we don't know what the initial velocity is. We know that time is t. Plus half into minus 0.4 into 10 squared. Okay, now let's see what do we have. We have 10 is equals 100 is equals to 10 u. Let's use the calculator over here. That's what I would recommend. 1 divided by 2 into minus 0.4 into 10 squared. 20. So minus 20. So 10 u is equals to 120. U is equals to what? U is equal to 12 meters per second. Okay, don't get carried away. This is not the end of the question. Why? Because what we have worked out is the initial velocity. Now, how can I use this to find out the final velocity? What formula can I now use? Assuming that we now have the initial velocity as well, which is 12, what can I do? I can use the first formula. Okay, that's correct. So the first formula is a is equals to u plus, v is equals to u plus at, or a is equals to v minus u upon t. So a is minus 0.4, v is v, we don't know what that is, minus 12 upon the time, which is given to us as 10. So what do we have? Let's cross multiply. So minus 0.4 into 10, that's minus 4 plus 12. So we now have the final velocity, which is 8 meters per second. Okay, now, I know what you guys are probably thinking. You're thinking that we could have used the formula, which I wrote earlier, Vt minus half At squared. You're right, we could have used that. But the reason why I didn't use it is because normally these are the formulas that are given to us, okay? This formula, if you know, that's great. But normally, students don't memorize this formula unless you're a physics student or something, because these are the 4 commonly used formulas. So yes, we can use that formula. That formula will give us the final velocity directly. But this is also, and by the way, there will be instances. There will be instances where you can have multiple ways of solving the same question. So there's no right way or wrong way. It's whatever method clicks to you first, and whatever method that makes the most sense to you. Okay. You're very welcome to try it out using that formula. You'll notice that you're getting the exact same answer. Okay, my apologies once again. Now, let's see what this question says. The reason why I've chosen this question is because in this question, you are supposed to remember those questions, those APGP questions in which the question says the sum of the first 4 terms is 100, let's say, and the sum of the next 4 terms is 150. How do you do those questions? Does anyone remember? If the question says the sum of the first 4 terms is 100, let's say, and the sum of the next 4 terms is 200, what do we do in those kind of questions? Simultaneous, yes, I agree. But how do you form 2 equations? That's what my question is. If, let's say, the question says that sum of the first 4 terms is equal to 100, and the sum of the next 4 is equal to 200, then how do you form an equation using this? Sum of the next 4 terms. I agree, use the sum wala formula, but what do you do with the information? Can I make an equation by using this piece of information alone? Sum of the next 4 terms. Is it possible?
No, I think you have to add them up, add both of the sums.
Yes. And then what do? We say sum of the 8 terms is 300. Okay? So you can't make an equation for sum of the next 4 terms. Okay? So if the question says the sum of, just a minute, let me finish. Sum of the first 4 terms is 100, and then sum of the next 4 terms is 200. Then since we can't make an equation using this piece of information, we combine the data and we say in that case sum of the first 8 terms is going to be 300. So we make an equation using this, we make an equation using this, and then we solve the 2 simultaneously. Now, why am I talking about this? Why am I even mentioning this? You'll find out in a minute. Nafi, Abdul Nafi, you were saying something?
No, sir, I had a question.
Acha, Ahmed,
Can
sorry.
you please explain it again, if it's okay?
Yeah, sure. So you remember APGP?
Yes.
Yeah. Okay. So if the question says, let's say the sum of the first 4 terms, this is T1, T2, T3, T4. Okay, and you're given sum of the first 4 terms is 100. Okay, and let's say you're told that the sum of the next 4 terms, is 200. That means sum of the terms from 5 to 8 is 200. So you can use a formula for sum and make an equation out of this. Okay, you can use this piece of equation. You can use this piece of information and make an equation. Obviously, that won't be enough for you to solve for the unknowns, but you can still make one equation, correct? But can you make an equation just using this piece of information? Yes or no?
No, you can't.
Then what do? You combine the 2. Okay?
Yeah.
So you combine the 2 and you say sum of the first 8 terms has got to be 300. So you use this piece of information, you make your second equation, you use this piece of information, you make your first equation, and then you solve the 2 simultaneously. Correct? Yes, Ahmed?
Yes.
Okay, great. Now, why am I mentioning this? Let's see, how is this related to the question? A trolley has a constant acceleration. After 2 seconds, it has traveled 8 meters, and after another 2 seconds, it has traveled a further 20 meters. Okay, do you see where I'm going with this? So here's what we're going to do. Let's make a straight line. Remember, it's always a good idea to make a rough sketch of what's going on. So here's your trolley. Any object that you have to show, make a rectangle. Okay, you don't really have to draw a trolley. You're not going to get any extra marks for that. A trolley has a constant acceleration. Okay. Now, after 2 seconds, that means after 2 seconds, it's probably over here somewhere. Okay, this is not drawn to scale. So in 2 seconds, it has traveled how many meters? It has traveled 8 meters. Okay. And then after another 2 seconds, okay, so after another 2 seconds, it has traveled a further 20 meters. All right. Now, how do we form an equation? Let's see. If I use this piece of information, what are we supposed to do, by the way? We're supposed to find the acceleration, okay? So we're supposed to find the acceleration. If I use this piece of information and looking at the 4 equations that we have, let's see, where do we stand? So these are the 4 equations that we have, okay? Can I use this formula? No, I don't have the initial velocity. I don't have the final velocity. U equals to 0? Nope. Don't make any assumptions. The question does not say that a trolley is starting from rest or anything of that sort. So please do not make any assumptions. I can't use this formula. I can use this formula, okay, except that I will have 2 unknowns. I'll have acceleration as an unknown and I will have the initial velocity as an unknown as well, okay? So if I use this in formula, let's see what happens. S is equals to ut plus half at square. S is what? S is 8. U, we don't know. We're not going to assume that it's 0. Into t, so that's 2, plus half into a into 2 square. So 8 is equals to 2u plus 4 upon 2. That's 2a. Okay, we can simplify it later on. That's not what's important. So here we have our first equation. Is this equation enough for us to find the value of a or the value of u? Of course not. Now my question is, how do we form the other equation? Are we going to use 2 and 20? Yes or no? Are we going to use 2?
No, sir.
What are we going to do then?
We will take the sum of both.
Yes, we will combine the information now. Okay, now I'm going to combine the information because it's not after 2 seconds. It's after another 2 seconds. Okay, and throughout what's constant? The acceleration is constant. Okay, so now time is equals to 4 seconds. The displacement is equals to 28 meters. Now we combine this in piece of information and form another equation. So 28 is equals to ut. That means 4 into u plus half a into t square. That means 4 squared. So 28 is equals to 4u. 4 squared is 16. 16 upon 2 is 8. So 8a. Now we have our 2 equations which we're going to solve simultaneously, find out the initial velocity and find out the acceleration. Okay. Now, any questions? While I'm
I had a question.
yeah, go ahead.
So if we can use 2 or 8 by equation, why not 2 and 20 by?
Okay, देखो. That doesn't make sense because we're saying कि 2 seconds में वो 8 meters पे travel कर रही है और only 2 seconds में वो 20 meters पे travel कर रही है. That doesn't make sense. समझ आ रही है बात? मैं कह रहा हूँ कि भाई 2 सेकंड में वो 8 meters पे travel कर रही है and at the same time I'm saying in 2 seconds it's traveling 20 meters. It doesn't make sense. Well, either it's traveling 8 meters or it's traveling 20 meters. Okay? And the time that we take, the time is always taken from the start of the journey. Okay? The time is always taken from the start of the journey. All right. So I'm just simplifying. I can see you guys have given me the answer already. That's great. So here's the first equation. If you simplify the second equation, which you can by 4, so you have 7, which is equal to u plus 2a. Now let's write it down as it is. 7 equals to u plus 2a. Now if you subtract the 2 equations, that way u gets eliminated and we just end up finding out the value of a directly. Minus 3 cancels out, equals to minus a, which means a is equals to 3 meter per second square. Now, as always, take a good look at it. Let me know if you have any questions. Does that answer your question? Yes or no?
Yeah, thank you.
Okay.
I just kind of slipped my mind.
Acha. Take it. By the way, let me tell you, solving linear simultaneous equations is something that will happen a lot in M1. Not just in kinematics, it will happen in connected bodies. It will happen in forces also. Yeah. Although in forces, equations are slightly different. But you make sure that you get the hang of this. The sooner the better. So let's solve this question. This is a question very similar to past paper questions. Okay, so gradually we're heading towards past paper questions. We will do some past paper questions today only. Okay, we won't do questions that involve gravity. We'll do questions that involve either a car or a train, stuff like that. So a car is driving along a straight horizontal road with speed 9 meters per second. When it begins to accelerate uniformly. Okay, so that means this is the initial speed and then it starts to accelerate uniformly. The car accelerates at 1.5 meter per second square for 216 meters. The driver then applies the brakes, which causes it to decelerate at a constant rate. The car comes to rest after decelerating for 4 seconds. Okay, now that's a lot of information to take in all at once. So what we're going to do is we're going to make a sketch to break the information down. So we're talking about a straight horizontal road. Here is your road. We're talking about a car. Here it is. Now, what is this car doing? It's accelerating for a certain time, applying the brake, and then coming to rest. Okay. So as this car is traveling, the initial velocity is 9 meters per second. Okay. The acceleration is 1.5 meter per second square, and the displacement up until the point that it hits the brake is 216 meters. Okay, so the displacement up until the point that the brakes are applied is 216 meter. Okay, basically means from this point to this point. All right, so all I've done so far is, if you think about it, I haven't really solved anything, but I'm pretty sure at this point this question looks much more solvable than it looked in the beginning. Now what happens as soon as the brakes are applied? Let's write it down. Here, this is the point where the brakes are applied. Then the car begins to decelerate, obviously, until it comes to rest at this point. Okay? And what happens? The driver then applies the brakes, which causes it to decelerate at a constant rate. The car comes to rest. So there's a lot of information hidden over here. What does it mean? The car comes to rest. The car comes to rest. What does that mean? Yes, that means the final velocity is 0, and it does that in 4 seconds. Okay, so it comes to rest in 4 seconds. Okay, all right. Find the speed at the instant that the brakes are applied. Okay, find the speed at the instant where the brakes are applied. That means we have to find out what? We have to find out the final velocity, but not the final velocity when the car comes to rest. We already know that. But the final velocity of the first part of the journey. That's what we have to find out. Okay, we have to find out the final velocity of the first part of the journey. So now that I've written all the information, let's look at the 4 equations that we have and then decide which one fits over here. So what do you guys think? Which equation can I use over here? First, second, third, fourth. The last one. That's correct. So we have the acceleration, we have the displacement, we have one velocity. We need to find the other. So we are going to use 2as equals to v square minus u square. So 2a, which is 1.5 into s, which is 216, equals to v square minus u square. Okay. Now just use your calculator and solve this. So 2 into 1.5 into 216 plus 9 square. So we get 729. Do not forget to take the square root. And if you do that, we get v is equals to 27 meters per second. What does that mean? That means just before the brakes are applied, the car is traveling at 27 meters per second. Okay? Now, 27 meters per second is basically the final velocity of the first part of the journey. What will it be of the second part of the journey from the point where brakes are applied? Think about it. Initial. That's correct. Okay? So any accounting students over here? Any accounting students from O level or A level?
Yes, sir.
Yes? Okay. So if you remember closing balance of 2022 becomes what?
Opening balance of 2023.
Exactly. Okay. You don't really have to be an accounting student, Vasa, to figure this out. But yeah, see, so the final velocity of the first part of the journey becomes the initial velocity of the second part of the journey. Okay? So,
I have a question though.
yeah, go ahead.
So you used 216 meters, but you were only using like a fraction of the actual distance. Is that okay?
Yeah. Because we're only dealing with the first part of the journey. So if you're dealing with the first part of the journey, we use all the information about the first part.
But the distance is for like the entire journey, 216 meters.
No. The distance is not of the entire journey. The distance is for as long as the acceleration is 1.5. It says the car accelerates at 1.5 meter per second for 216 meters. The driver then applies the brakes. So after it has traveled 216 meters, that is when brakes are applied. Okay, so I made these 2 arrows representing 216 meters.
Alright, got it.
Okay. All right. So what do we have? We have the initial velocity. We have the final velocity. What do we have to find? We have the time as well. What do we have to find? We have to find the acceleration. Okay. So can you guys do part B and tell me what the answer is? I've done all the hard work. That is correct. 6.75. Good job. 6.75 is the correct answer. 27 over 4 or 6.75. Good job. Okay. Now, let's do some past paper questions.
So could you solve this, please?
Yeah, sure I can. So, what is the information that we have? We have the initial velocity, we have the final velocity, we have the time, we need to find out the acceleration. Yeah?
The deceleration would be a negative, right?
No. The acceleration would be negative. If you're giving deceleration, that we will give without the negative sign. Okay? So, Al-Azhar, we are given the initial velocity, we're given the final velocity, we're given the time. And we need to find out the acceleration. What formula do you think I can use over here? The first, second, third, fourth.
So perhaps first one.
That is correct. That is correct. Because we have V, that's correct. So V, which is, let me write down the formula that we're using. V equals to U plus AT. 0 is equals to U, which is 27, plus A into T, which is 4. So 4A equals to minus 27. A is equals to minus 6.75, which is the correct answer, but I'm afraid it can potentially cost you 1 mark. Why? Because the question is saying deceleration. Deceleration means that you're not supposed to give it with the minus sign, so we just write 6.75 meter per second square. There you go. Okay, does that make sense?
Right, sir.
All right.
Okay, right, sir. So velocity is equal to 0 when the brakes have been applied completely, right, sir?
No. Don't make a standard rule. Velocity is 0 because the question says that it comes to rest. Okay, so here's a question. It's a very lengthy question, but the good news is it's not that difficult. Okay, so let's try and solve this question together. And remember, do not shy away from making a sketch. Okay, it's very important. If you make a sketch, you have a clear understanding of what's happening in the question, and then that way you're more likely to get the correct answer. And these are, although it's a 6-mark question, that's the bad news, but the good news is it's very easy. Okay, it's actually very easy. And look at the amount of space that you're given. And chances are that we will probably be done with half the space that's given. Okay, not half the total space, half the space that's given on the first page. Okay, so a particle P moves in a straight line ABCD with constant acceleration. The distances AB and BC are 100 and 148 meters respectively. Okay, the particle takes 4 seconds to travel from A to B and also takes 4 seconds to travel from B to C. Now this is a multi-stage journey. Okay, this journey is not the same throughout. Yes, the acceleration is constant throughout, okay, but this is divided into 2 parts. One is from A to B and then from B to C. In fact, later on you will see that it's actually from C to D as well. So it's divided into 3 parts altogether, but in the first part it's divided into 2. Okay, so first thing we do is we make a line representing the distance. Okay, now let's read the question again and let's pick key information. The distances AB and BC are 100 and 148 meters respectively. So that means this could be B, this could be C. Okay, and the distances are, and this is A by the way, 100 meter and 148 meter respectively. Okay, I hope you guys are following. Then it says yeah, go ahead.
Sir, why do we write S in place of distance? Like, what does that word mean as?
S is basically displacement. S is basically displacement. But here, since the particle is not turning, if you remember, for as long as the particle does not turn, what do we say about distance and displacement? They're both equal. Okay.
Right, sir.
S represents displacement, which is equal to distance for as long as the particle does not turn. Okay. All good now?
Yes, all good.
Okay, great. All right, now let's resume. How long does it take to travel from A to B? It takes 4 seconds. Oh, brilliant. You've given me the answer already. So the time is 4 seconds. How long does it take to travel from B to C? Also 4 seconds. Okay. Acceleration is constant, so A is equal to A, and here also A is equal to A. Okay, they're not different. Now let's break this journey down. Let's talk about from A to B. From A to B, the distance is 100 meter. The time taken is 4 seconds. The acceleration, we don't know. The final velocity, we don't know. The initial velocity, we also don't know. Okay. So what formula can I use here? What formula can I use over here? Just a minute. Yeah, I can use the second formula. S is equals to ut plus half at square. So I'm just going to paste it over here. Okay, here it is. So if I use S is equals to ut plus half at square, notice what happens. 100 equals to 4u plus half into a into 4 squared. So 100 is equals to what? 100 is equals to 4u plus 4 squared is 16. 16 upon 2 is 8. 8a. Okay, so it's turning out to be we're very close. Okay, it's gradually looking like a solvable question. Now the next part of the journey is from B to C. So now the information that I will consider, what will that be? What will be the displacement? 148? 248. Very good. Why? Because now the journey that we're considering is not from B to C, is actually from A to C. Remember the example that I gave of sum of terms? Just like that. So here you're given from B to C, but now we're combining the two, and the displacement is 248. Okay. The time is going to be 8 seconds. Yes, good job. Acceleration will be the same as the previous part of the journey because it's constant throughout. Okay. And then we don't know the final velocity, we don't know the initial velocity either. So we're going to use the same equation, S is equals to ut plus half at square. In this case, 248 is equals to ut, so that means u into 8 or 8u plus half into a into 8 squared. So 248 equals to 8u, 64 upon 2 is 32, so 32a. Okay, now that you have your two equations, equation 1 and equation number 2, solve simultaneously. Solve 1 and 2 simultaneously. And what do you have? You have u to be equal to 19 meters per second. I'm just saving some time and giving you guys the final answer. A will be equal to 3 meters per second. Okay, we're given the value of A actually. So there you go. This is the final answer. Any questions? If yes, feel free to ask. Notice how.
Sir, I had one question.
Yeah, go ahead.
Sir, if the acceleration is not constant, sir,
Mm-hmm.
how will we treat the question?
So,
We form the whole two different equations, right?
yes, we'll form two different equations, and these questions are called, this category is called constant acceleration because in this, acceleration is constant throughout. Okay, but to answer your question, if it's not constant, then we basically divide the journey into two parts and we form two separate equations.
Okay, so we will not face any unconstant questions, right?
No, you won't. You will, for example, like you did over here. Sorry, not over here, like you did over here. Yeah. Here you were given 1.5 as the acceleration, but then after the brakes were applied, then the acceleration became different. Okay. Now we were looking at only this part of the journey. Okay, we didn't combine the two because the acceleration is now different. Okay. But throughout one journey, it's going to be constant. So for example, if it's accelerating from point A to point B, from point A to point B, the acceleration will be constant. If it's decelerating from point B to point C, from point B to point C, throughout the acceleration will be constant. Okay? So that's why we call this concept constant acceleration. Okay?
Right, sir, got it.
All right. Yes, Momina, final velocity. So basically, we have u. That means we have the initial velocity. Now, if we can find the final velocity, that will then become the initial velocity from B to C. Okay, let's see. Let's solve it, see what's what. The next part says, so notice that this is a 5 plus 3, that's 9, almost 10 marks. That means 20% of your paper is kinematics. Okay. Okay. It says P reaches D with a speed of 61 meters per second. Find the distance CD. Okay. P reaches D with a speed of 61 meters per second. Find the distance CD. Okay. Now, so remember, here's A, here's B, here's C, and here's D. Let me see if I've worked out all the exactly what we were supposed to. Yeah, we have. Acha, wait a minute, wait a minute. We also had to find out the speed of P at A. Okay, we've done that. That's the initial velocity. Okay, great. Okay. Now the question says P reaches D with a speed of 61 meters per second. What do we have to do now? We have to find the distance CD. Okay? Now, here's what we're going to do. Remember, throughout the journey, what's constant? Throughout the journey, the acceleration is constant. Okay? So the initial velocity at A was 19 meters per second. Okay? Throughout this journey, the acceleration is constant. So if the acceleration throughout the journey is constant, we don't have to break it down. We don't have to break it down from A to B, B to C, C to D. We don't have to do that. Okay? What we have to do is we need to see what the final velocity is because it's reaching D with a speed of 61 meters per second. And throughout the acceleration is constant. Okay, remember that the question told us at the very beginning. The acceleration is constant. Okay. Now, what do we have to find out? We have to find out the displacement. Keep in mind, we do know that the acceleration is 3 meter per second square. What we need to find out is the distance. Okay, we need to find out the distance CD. Now tell me something. Although we need to find out the distance CD, can we find out the total distance? Using the information that we have, can we find out the total distance? S is the only unknown so far. What equation can I use in order to find out the total distance? Let's look at the equations here and tell me. What equation can I use over here to find out the total distance from A to D? Take a closer look. The last one. That's correct. I can use the last equation to find out the distance from A to D. So here's how that works. 2as, that means 2 into 3 into s, equals to v squared, which means 61 squared minus 19 squared. Now let's solve this. 61 squared minus 19 squared divided by 2 into 3, which is 6. S is equals to what? S is equals to 560. Now, is this the final answer? Can this be the final answer? Of course not. Okay, don't get carried away. This is not the final answer. The question is asking us to find what? The question is asking us to find the distance from C to D. We already know the distance from A to B is 100. We know that the distance from B to C is 148. We need to find CD. So in order to find the distance CD, we will take 560. From it, subtract 100 and 148, which is 248. So CD turns out to be minus 248, 312 meters. And there you go. That's your answer. As always, take a good look at it. Let me know if you have any questions. Okay, one last question. And then that will be it. I will be giving you guys some questions to solve as practice. Here is the question that you guys should solve right now. 6-mark question from May, June 2019, paper 4, variant 2. Yeah, you're not going to use the second formula. In fact, you're going to use the third formula. Okay. So first of all, see how many unknowns do we have over here? How many unknowns do we have? 2 unknowns. Okay. What does that mean? That means we will need 2 equations. Yes, Momina, acceleration is 8 upon 3. That's the correct answer. 8 upon 3 and 28 upon 3. So a car moves in a straight line with initial speed u. Sorry?
I got A as 1.74.
1.74.
Yes.
No, it's 2.66. 2 upon 3. 8 upon 3, sorry. Okay, I'll solve this. Pay attention. probably made a calculation error. Let's first understand what situation we're in. A car moves in a straight line with initial speed so and so and constant acceleration. The car takes 5 seconds to travel the first 80 meters, okay? And it takes 8 seconds to travel the first 160 meter. Okay? So first tell me, are we going to combine these two pieces of information?
Yes, sir, simultaneous equation.
No, I agree. We will make simultaneous. We will form two equations and which we'll solve simultaneously. So tell me if you're going to add 160 to 80 just like we did previously and we're going to add 5 and 8. No, why not?
No, sir.
Why not?
So because the first 160 meters
Exactly.
starting from the beginning.
Exactly. So if the question said maybe next 160 meters, then we would have combined the two. Okay. So here's what we're going to do. Let's write down the information that we're given. So we don't know what the initial velocity is. We don't know what the acceleration is. We know what the displacement is. That's 80. We know what time it is. It's 5 seconds. Okay. So this is for the first piece of first part of the journey. Then for the next part of the journey, the initial velocity is again this obviously going to be the same. The final the acceleration is constant. The displacement is 160. Time is going to be 8 seconds. Okay. Now we need two equations since we have two unknowns. The question is how are we going to form the two equations? So here's what we're going to do. S is equals to ut plus half at square. Okay, can we use this? S equals to ut plus half at square. We have S. We don't have u, but we have t, which is 5, plus 1 upon 2 into a into 5 squared. Okay, so let's write this nicely. 80 is equals to 5u plus 12.58. 25 squared is 25, or 5 squared is 25 divided by 2, which is 12.5. First equation. Okay, let's park this here. Now let's use 160 meters, which is equal to u into 8 plus 1 upon 2 into a into 8 square. So 160 is equals to 8u plus 8 square is 64. 64 upon 2 is 32. So 32a. Solve these two equations simultaneously. Notice you have plenty of space and then find the value of a and find the value of u.
Wait, sir, can you solve these? Because I made a calculation error and I can't tell where I went wrong.
Okay. You got the two equations correct?
Yeah.
Okay. What method are you using? Substitution, elimination?
I eliminated the u and then I added everything together.
Okay. So let's simplify this equation. These are all multiples of 8. So 160 divided by 8 is 20 equals to u plus 4a. Is this what you got?
Yes, it is.
Okay. So let's multiply this by 5 so that it becomes 5u. So 100 equals to 5u plus 20a. Now let's write this over here. 100 equals to 5u plus 20a. Now let's subtract the two equations. So 80 minus 100 is minus 20. 5u gets eliminated. That's the idea. 12.5 minus 20 is going to be minus 7.5a. Now do minus 20 divided by minus. In fact, just cross out the two negative values, two negative signs. 20 divided by 7.5 gives us a, which is equal to 8 upon 3 meter per second square. And there you go. That's your answer.
Oh, I've been adding instead of subtracting.
Oh,
so
okay. Use your calculator to always check your answer. Sir, does the examiner expect us to show the working for simultaneous equation? Momina, that's a very difficult question to answer because if I say no, I'm afraid you might end up losing marks. If I say yes, then... So, I'll give you an easy way out. Easy way out is that you show the working, okay, not with the intent of, or not with the purpose of solving your answer through the working. Just show your working and then use your calculator to write the final answer.
So I have a question.
Okay, just a minute. All right, does that answer your question? Just like if let's say you have to use a quadratic equation, you have to use the quadratic formula. So you write down the formulas with the values plugged in, use your calculator, and then just write the final answer. How much of the working? That also is a good question. Dekho, when you have equations like these, when you have equations like two linear equations, in that case, just show the elimination part, okay? And then you can write down the final answer. Okay, just show the elimination part and then write down the final answer. Okay. Yes, Nafe, your question.
I saw the question exactly the same way. I just got confused that I added both the equations. I don't understand like when do we add the equations and when not to add the equations.
देखो 5u है ना, and here also we have 5u. What happens if I add the two 5u's? Think about it. What's 5u plus 5u?
Oh, not in this case, like जो.
Oh, you mean this information 80 और 160 को ऐड कब करना है? देखो बहुत सिंपल सा जवाब है. Had the question said that it takes 8 seconds to travel the next 160 meters. In that case, that means, see, the equation that we form is from the start of the journey. Okay, if the acceleration is throughout constant, that means the equation that we form is from the start of the journey. So if the question had said that it takes 8 seconds to travel the next 160 meters, then there's no equation for the next 160 meters. In that case, what we would have done is we would have first added the two distances, added the two times, and then formed an equation and then solved the two simultaneously. Here, since the question says that it takes 5 seconds to travel the first 80 meters and it takes 8 seconds to travel the first 160 meters. That means वो शुरू से ही बात कर रहा है. First 160 meters means that it's talking from the beginning as only. So that's why we don't have to add the two. If let's say the question said, again, always go back to the sum of n terms example. If let's say the question said that the sum of the first 4 terms is 100 and the sum of the first 8 terms is 300. In that case, are we going to add the 100 and 300?
Yes.
Okay, listen to my question carefully. Sum of the first 4 terms is 100. Sum of the first 8 terms is 300. First 4 terms, first 8 terms. No.
No.
Okay, but what if the question said next? In that case, yes. यहाँ पे भी वही example है. First 160, if you go back to the previous example, हाँ, अब for example यहाँ पे आप देखें AB is 100 and 148, BC is 148. So this is 100 meters, these are your first 100 meters, these are your next 148 meters. Okay, so
इस केस में whether कि ABE is 100 और AC is 148 फिर हमें ऐड करने की जरूरत ना होती.
yeah, of course. If the question said AC is 148, so for that means you're measuring from the same point.
Okay, thank you.
Okay. Sir, can we schedule a class to discuss the questions? Yes, we can do that because we've covered quite a lot. So we can schedule a class to discuss all the questions. So here's what I'm waiting for. I'm waiting for us to cover all the concepts. Okay. Then, before we move on to the next topic, we will schedule a class to discuss all the types of questions. All right. So I'll stop here. See you guys, inshallah, in the next class. Until then, take care. Allah Hafiz.